We are really focusing on the AEF activities in that perspective and about the importance of being AEF certified. We're gonna leave the floor to Marcel Huben from AEF office and to Andrew Oliver, chairman of the AEF. Thank you, Marcel.
Alessius, thank you to give me a part of minutes here to present something about the AEF. And at first I share you the agenda. At first we take a short introduction and welcome round. Then Oliver presents something about the AEF. Then cross-manufacturer communication. That's the reason why we need this AEF conformance test and have these AEF tools. Then something about the AEF database and at least the AEF conformance test. So some words from my end. My name is Marcel Urban. I'm working for the AEF as AEF IT coordinator since January 2023, and I'm responsible for the AEF database. So we have a team direct in the AEF, which is propose and prepare the AEF database and summarize some feedback from the field. Then I'm the Microsoft SharePoint administrator. In the SharePoint, we store all AEF data and share these data to all manufacturers that are a member of the AEF. And then I'm also a member of the service and diagnostic group in the AEF. Okay, then I would hand over to Andrew to present a little bit of the AEF.
Okay. Oh. Thank you, Marcel. He always leaves me the good bits. Okay, so for those who weren't here before, I'm Andrew Oliver. I'm the chairman of the AEF, and I'd like to give you a little bit of an overview of the history of the AEF. So if we go back to the late 80s, and no, I won't go there. If we go back to the late 80s, obviously electronics were starting to come into agriculture, and people were starting to realize that if I add some type of control system, I can do a better job. I can make a recording of what I've done. And with this, if you like, entrance of electronics into ag equipment, then there was obviously the need that, well, maybe we need to have some type of interoperability. Maybe we need this electronics from different manufacturers to work together. And this did start in the late 80s, and we sort of, you know, if we look forward to the early 90s, or possibly the mid to the late 90s, there were actually, if you like, two kind of streams, two different ideas on what is the right way to have this interoperability, what is the right type of bus and language on the bus that we could have in agriculture that it would allow tractors and implements from different manufacturers to work together. There was quite a pivotal meeting in Germany at the, I think, the VDMA headquarters in about 1998, and there was a decision made between, is it going to be the LBS system, the land bus system, or is it going to be, if you like, what became ISOBUS? And thankfully, the decision was, let's go in this ISOBUS direction, and that paved the way for this first standard, ISO 11783, this common CAN bus, this common electronic network that could go between tractors and implements and displays from many different manufacturers. The whole idea behind, if you like, ISOBUS was that by having this common CAN bus, we could end up having, okay, I develop the system on my tractor, you develop the system on your implement, but by following the same language, we can actually get things working together. So in the end, the standard was developed, and it was developed under the ISO organization. That's why it is ISO 11783, and it was developed by an ISO working group, which was made up of engineers, technical experts from a number of different OEM companies. And in the end, that standard was released, 2000, 2001. And it was viewed, if you like, as the holy grail. This will give us interoperability. This will give us plug and play with ag equipment. We're not stuck to buying tractors and implements from the same manufacturer. We're not stuck to buying implements and having to buy all their electronics, including their display, and adding another display to the tractor cab. So it was viewed as a really good thing for the ag industry. Unfortunately, in those kind of early years, 2000, 2005, 2006, everybody was developing according to this new standard, and everybody was discovering that we were still seeing interoperability. We were seeing equipment that was not working together. ISOBUS, ISO 11783, wasn't delivering on what was promised. And we also saw the formation of 2 or 3 different regional groups to try and get together to address this problem. In North America, there was this North American ISOBUS task force. In Brazil, it was, I can never remember the exact word, but basically it translates to Task Force ISOBUS. And in Europe here, it was the IGI, ISOBUS Implementation Group. Okay. In the end, there were these 3 regional groups trying to work out how can we make ISOBUS better. What happened is we decided as an industry, rather than having 3 regional groups, let's try and form one group of a global nature which can work on making ISOBUS better. And that group is essentially the AEF. This is what led to the founding of the AEF in April of 2008. The AEF standing for the Agricultural Industry Electronics Foundation. The original founding members were 7 of the large ag equipment OEMs and 2 trade associations. If we go from 16 years ago up until now, we now have, from those original 9 members, we now have over 302, or just over 300 member companies participating in the AEF. And really the reason behind the AEF is we're not a standards body. We're a group that comes together, our members volunteer their time, their technical expertise to work in teams to investigate where there's a problem on the ISOBUS. And they come together and they talk about, okay, what is the problem that we're all seeing on this particular aspect of the ISOBUS? What can we do to improve the situation? How can we document what makes it better? And that work is done in terms of AEF project teams. So, this AEF, it's a volunteer organization. Any company that belongs to it pays a membership fee, and then they're, if you like, asked or they're encouraged that they allow their engineers to spend some time supporting these AEF project teams on a voluntary basis. How can we come together? How can we work on a problem with ISOBUS compatibility and make it better? And that's really, if you like, the foundation of the AEF. Ultimately, what we do is we end up documenting the solution in an AEF guideline, and that AEF guideline is available to any member company to use as they're developing ISOBUS systems. And then once that guideline is released, we also inform the relevant ISO working group, and in most cases they will take the contents of our guideline and include it in the next revision of the ISO standard of 11783. So whilst we're not a standards body, typically the work that we do ends up getting included in the next revision of the standard. We've really been focusing on ISOBUS, how to make ISOBUS better. That's kind of why the AEF was started. But we've kind of found that we have this good, if you like, spirit of collaboration within the ag industry. So that's led us to sort of create newer and newer project teams. So a team working on wireless in-field communication between different manufacturers, a team working on high-speed ISOBUS, having an Ethernet bus going between tractors and implements of different manufacturers. We've got a team working on how can we connect our ag clouds together, standardized API for ag equipment manufacturers to easily connect the clouds. And then, as mentioned before, we've just started a team looking at autonomy. How can we look at autonomous applications, look at the interfaces which should be standardized, and work on those standards or standardizing those interfaces. So it's all based around interoperability of ag equipment. So we've, if you like, graduated or evolved our scope along improving just, you know, the basic ISOBUS. And here's really a shot, although this is possibly not quite up to date, of 302 member companies. So our membership is companies from around the world. We also have membership from trade associations such as, you know, in Italy, FederUnacoma is a member of the AEF. They're on our steering committee and they get to participate in the decisions that we make. Represented thanks to Alessio there. And then we also have educational institutions, universities belong to the AEF because they're interested in teaching about ISOBUS, they're interested in how the standard developed, etc. So we have membership from many companies around the world, and our membership seems to be growing at around 30 companies per year, which is quite exceptional. So ISOBUS, we as an industry collaborated to develop ISOBUS in the first place. We got it released into the industry. We discovered there were problems, so we as an industry ended up creating this group, the AEF, to work out how to make ISOBUS better. How can we collaborate as an industry to make ISOBUS better? We started talking about ISOBUS in terms of functionalities to make it easier to understand what you can do with an ISOBUS system. We developed a conformance test for those functionalities, and we developed a database where you can see conformance tested products. So again, we're trying to make ISOBUS easier to understand and more transparent for the whole industry, and that was really the reason why the AEF was formed. I will hand over to Marcel to continue the presentation.
Yes. Thank you, Oliver, to present the AEF, and I go further with this cross-manufacturer communication. So Andrew talked a little bit about the ISOBUS and what is the ISOBUS. The ISO standard, when we are talking about ISOBUS, is the ISO standard 11783, and in this standard we have different kind. It's more louder. Okay, when I'm standing in front of you, it shows a little bit other. Okay, so I go back. When we talk about ISOBUS, we talk about the ISO standard 11783, and in this standard we have different kinds of, we named it in the AF, we named it functionalities, and with these functionalities we can describe the universal terminal, the task controllers, the aux functionalities, the file server functionality, and also the TIM functionality that we have in the ISO standard. Then also the communication between the tractors and the implements. So everybody needs a tractor to steer an implement, and with that we also, in additional, we need any terminals for that. So here's a short example of a standard ISOBUS network. So we have here the tractor side with the ISOBUS connector on the end of the tractor. We have an ISOBUS connector for the workshops to read out some failures of the ISOBUS, and then we have the ISOBUS in-cab connector where we have the possibility to add some joysticks, to add some terminals, and so on. So the kind of ISOBUS is a tractor and an implement. We will see here for this picture, it's a kind of sprayer, and we have top of there, we have a laptop with a kind of diagnostic software. So then we go back to the functionalities. Each functionality describes a specific ISOBUS system. So we have universal terminal, aux new, aux old, and the reason is why we have aux old and aux new, we get an update in the functionality. In case when we describe functionalities, we talk about that each functionality is backwards compatible. So for the UT, we are in the 3rd generation of UT, but it's already compatible with the first version of the UT. But not for the aux new or aux old functionality, so we have an update. That's the reason why we have 2 different icons with 2 different functionality names. So aux old and aux new is not compatible to each other. So then we have also task controller basic, task controller, section control. I think the most of you knows the section control function that on the field, on a tram line, we shut up some rows from the sprayer or some nozzles from the sprayer. Then task controller Geo, tractor ECU, and we have TIM and file server. So go back to this here. I said it some minutes before with the backwards compatibility in these ISOBUS functions. So also these functions is for the manufacturer a good way to implement, sell tractors with, it's an open concept for with these defined functionalities. So then we have here a short example. I have on the right side my tractor with the UT, task controller basic, and the TIM functionality. And on the left side, I have my loader wagon or wagon also with the UT, task controller basic, and the TIM functionality. And we will see these blue fields on each side. We know that the functionalities work each other in this kind of combinations. So it was a lot of words for something, yeah, it's a simple thing, but that's the reason why we investigate in the AEF database. Oh, one more slide. We have, I missed that one more slide. We have the AEF certified label. When you go around on the booth or on the ferry, on some machines you already see our AEF certified label. And all machines that have the AEF certified label are also part of our AEF database. So then we come to the database. It's my main part in the AEF. And the database is developed also in the beginning with the AEF. And in the database, we have a list of all manufacturers that have certified products in the field. So each product which is certified can the manufacturer upload to the AEF database. So, and also with the database, the manufacturers or the developers from manufacturers do the conformance tests. So they generate a kind of information for the software and ask a test lab for the certification. For test labs, we have here the White Test Lab in Germany, we have the ISOBUS Test Center. In the US, we have the Nebraska Test Lab and some more test labs around the world. Okay. Then we go to the ISOBUS certification process. We have here, we named it CCID. This is generated from the manufacturer code, from the year, from the code from the test lab. So each test lab has its own 3-digit code, and we have a number that it's grown up with each CCID. And here we can see that there's only, for example, the manufacturer Kuhn, a manufacturer John Deere, Querneland class asks for test by the test labs. We have here Kuhn and Querneland class choose the ITC test lab, and John Deere choose the DLG test lab. So then for the certification process, with each release of a software, a manufacturer must do a certification in a test lab. So with the, I called it version 1, they go to a test lab with a software and ask for software certification. So then the test lab choose our conformance test tool, which is based on our AEF guidelines. And the conformance test asks some information from the software. Hey, what are you doing? You're an implement, you're in virtual terminal, you have these functionalities. And then the conformance test runs his test, and you get feedback direct from the test. But when you pass the first test, you have also the possibility to do a self-retest 2 years after the official test at the test lab. So also during the development of software, you have the possibility to change some information in the software, and you can develop with the conformance test tool direct on the new software. And when you're done with your software, here for example version 1.8, you can do self-certification, get a certificate, and upload your information to the AF database. So when a customer or a farmer go to a database and can see, oh, version 1 is certified, version 1.8 is certified, and so on and so on. Okay, then we go to the conformance test. The performance test is described to make sure that the compatibility between ISOBUS products is really given between different manufacturers. Then we have 5 of these test labs. I told you the test center, the Rye and the Nebraska, and also we have the Caraval from France and the DLG test center from Germany. So with the conformance test, the developers can download the ISOBUS conformance test tool in our AF database. The conformance test is then a desktop application, so you can download it to your desktop. You need a kind of VCI to connect the conformance test to the terminal or the implement and so on. And then your connected system is tested with this software to the computer. So then for conformance tests, we have also, Andrew told you that we have project teams in the AF, and also we have 2 teams, which is one for the conformance test and one for the database. And in this conformance test team, we have these experts from the manufacturers in this team, which are write the or set down the requirements for the conformance test. But all these requirements are based on the ISO standard or based on an AF guideline. And based on these requirements, the manufacturer who provides the, or not the manufacturer, but the developer who provides the conformance test to the AF can write these test cases. And then we have for each guideline, for each ISO standard, we have a conformance test and we can test. So here's a short example. I know it looks very difficult, but for me it's also a bit difficult. So the conformance test asks different slots from your software, and then you get for each slot or for each CAN message and feedback, is this message describes direct, or is this the same like we describes in the AF guideline? And then we can see here all these things are passed and one is failed. So the performance tests for this example are not passed. Thank you very much. Any questions from your end? Yes.
Just so that everyone can hear me. I'm curious to understand a bit more about ISOBUS and how it works. I'm very new in this world. So when you talk about the certification and the test to be passed, are you talking about only the connectors or the whole appliance, like the tractor, the implement? And when you give a certification, do you give it solely to a John Deere or CNH, or to an NFNL or whoever?
Yeah, thanks for the question. Can we go back to the... Okay. So we have this picture with... One more second. No? But when we talk about ISOBUS, we talk about the whole ISOBUS network with an implement, with the tractor, with scroll a little bit up, with the connector, with terminal, with joysticks, with all additional things on the ISOBUS. And the certification, each manufacturer that are provided ISOBUS things to the market. It's not only the big OEMs, but it's also, for example, My Easy Farm. It's smaller manufacturers that only have one product or have one joystick, because in the database we have, I think, around 80 manufacturers which are providing ISOBUS stuff. So the conformance test is possible for each member of the AF, for all of these 300.
And in the end, if we talk about the conformance test, first of all, there's a test for the hardware. So you need to certify that an ECU is, compliant to a certain standard. And then there's a test for the software. And in one of the slides that Marcel was showing, he showed an ECU or a display with, if you like, an evolution of software versions over, a period. And most OEMs have at least 2 software releases every year, two firmware releases. And really the request from the AEF is that every firmware release is certified. Obviously, most manufacturers don't actually follow that rule. However, that's kind of really the request from the AEF. When we put this whole, if you like, system or concept together, I mean, we all had experience with ISOBUS from the early 2000s. We all had the experience that we have incompatibility on the ISOBUS and we don't know what actually works with what. So we formed the AEF. We said, let's talk about ISOBUS in terms of functionalities, those little blue squares. You see a UT square on the tractor, you see a UT square on the implement, you know that's a common functionality those two share on the ISOBUS. And then we thought, okay, it's all very well having a common naming convention, because if you look at the standard today, it's well, even when it was first came out, it's 14 different parts. And people were saying, okay, I've got an ISOBUS system, I've got something which is using part 6 and part 10 and whatever, but nobody really knew what that means. So that's why we came up with the functionality concept. Blue square on the tractor, blue square on the implement, they share that functionality. And then we said, okay, well, how do we know it's trustworthy? Let's develop a conformance test for those functionalities. And that's really what we're talking about. We're talking about a conformance test which tests the hardware and then the software for a particular, if you like, conformance or compliance to 11783. But not only, I mean, the nice thing about the conformance test, it's an AEF conformance test. So when we have a guideline which has been updated and which is kind of more ahead of the standard, we can update our conformance test so that the conformance test represents the ISO standard and the relevant AEF guideline. The whole idea behind the conformance test, when you certify a product and it's certified thanks to the AEF conformance test and the manufacturer loads it into the database, that certification is a guarantee that that product is compatible on the ISOBUS. So if you're then in the field and you have something on the tractor which is ISOBUS certified and you have an ISOBUS implement which has nothing certified and there's an incompatibility issue, then the investigation should always start with the non-certified component, because the certified component is guaranteed to be compatible on the ISOBUS. That was the reason behind developing the conformance test, and the conformance test is one of the kind of reasons why the AEF was formed. We wanted to make ISOBUS a workable system for the ag industry. Okay, I talk too much. Any other questions? Okay, thank you.
Thank you.
Maybe I just jump in for a couple more minutes just to say, if you want to know something more about the ISOBUS, there's a nice chance to have some chat downstairs, 5:30. Happy hour of the AEF, sponsored by DigiDevice, is happening at the AEF booth. It's just downstairs, underneath these the stairs here. And I'd just like to remind the program about from tomorrow in this area, starting at 10 o'clock, talking about artificial intelligence with SEMA and manufacturers. And then at 14 in the afternoon, we are talking about the trends and the challenges of the digital agriculture with the Osservatorio Smart Agri-Food from Politecnico di Milano, University of Milano. AEF new trends, we're talking about autonomy, we're talking about AGIN and high-speed ISOBUS. And we are gonna closing up at 4 in the afternoon talking about data, cybersecurity, and artificial intelligence in the new European legislative framework with the SEMA representative Ivo Ostens. Thanks again for being here for these couple of hours. Maybe we'll meet each other downstairs or we meet each other tomorrow. Thank you.